Okay, the second topic is the redox reaction. The previous session we discussed the moles question. Now some redox reactions and the questions related to redox. So first, the definition of a redox reaction, the reaction in which oxidation and reduction happen. That reaction is known as redox reaction. So reaction in which oxidation and reduction occur, we call simply that as a redox reaction. So to understand this oxidation and reduction, because there are many definitions for oxidation and reduction, the definition which is valid for all the scenarios is about the electrons. But it can be defined in many ways, like the definition which can be used for all type of reactions is in terms of electron. So, and you will remember from oil rig, O stands for oxidation, I stand for S, and L stand for loss. So oxidation is loss, but loss of what? It is a loss of electron. R stands for reduction, I stand for S, and G stands for gain. So reduction is gain, and gain of what? It is also a gain of electron. So this definition of oxidation and reduction can be applied for any chemical reaction. But other definition which involve oxygen or hydrogen is only specific for certain reactions, not valid for all type of reaction. So the universal definition for oxidation and reduction, oxidation is a loss of electron and reduction is a gain of electron. But there are other definitions for oxidation. You can also define oxidation as addition of oxygen, that is called oxidation. You can also say removal of hydrogen, that is also called oxidation, or you can also say increase in oxidation number. What is oxidation number? That we'll discuss in this session. So if oxidation number increase, that also called oxidation. Same way, reduction is having other definitions. Reduction can be removal opposite of oxidation, so it is removal of oxygen. It can be addition of hydrogen, or it can be decrease in oxidation number. So these are the definitions which can be applied for reactions, certain reactions. In terms of electron, you can apply for any kind of reaction. Now, example, oxidation reduction in terms of oxygen. So example, we have zinc oxide reacted with say carbon monoxide. It changes into zinc. and carbon dioxide. Now the question is, identify which reagent oxidation happen and which reagent reduction happen. So we have zinc oxide initially, and that becomes zinc. So if zinc oxide changes to zinc, when we check this change, what happened? It means it is a removal of oxygen. So if there is a removal of oxygen, so which definition is removal of oxygen? When we check removal of oxygen, what we call that as reduction. So actually this change is reduction. Same way, if you check carbon monoxide, for carbon monoxide, first it is CO, then it changes into CO2. So it means this change is addition of oxygen, and if this change is addition of oxygen, what we call? So we call that as oxidation. So we can identify this reaction in terms of oxygen. So it was easy because oxygen was given, or there we can simply use oxygen and identify whether it is oxidation or reduction. Addition of oxygen is called oxidation, removal of oxygen is called reduction. But some of the reactions does not, like not all of the reaction involve oxygen. There are some reaction in which we don't have oxygen. Like example, if there was zinc chloride was reacting with calcium, it turned into calcium chloride plus zinc. Now when you check this reaction, in this reaction you don't have oxygen, you don't have hydrogen, so it is difficult to identify oxidation and reductions. For these type of reaction in which you don't have oxygen or hydrogen, or no charges or electrons are given, so best way to do this question or identification, you will check by oxidation number. But what is the oxidation number? Oxidation number is a charge appear on the element it is charge appear on the element when they form compound. Yes, it is like a valency, the same as a valency. So group 1, first thing, in element state the oxidation number is always 0. When you have element, like example chlorine Cl2, fluorine F2, oxygen O2, sodium Na, magnesium Mg, potassium K, copper Cu. These all are element. Whenever elements are there, what is the oxidation number? So oxidation number is 0. Even the element is monoatomic or a diatomic, all the elements, their oxidation number or charge on them is 0. But when they form a compound, the oxidation number is similar to that of valency. So depending on the group, the common oxidation number for group 1 it is +1, group 2 +2, group 3 +3, group 4 common one +4, group 5 -3, group 6 -2, group 7 -1, and group 8 the oxidation number is 0. In higher classes like in A levels, you will learn more about oxidation number, and you will find in A level that it is not necessary that there should be -3 for group. It can be +5 as well, but that is in A level, so I'm not making it complex. Just the charge group number will decide the oxidation number. In O levels, you will keep this information in mind. And for transition element, the Roman number shows the oxidation number. Like example, if I say copper 2 oxide, copper 2 sulfate, iron 3 oxide. So when we say this, copper 2 oxide, this Roman number is representing what? It is representing the oxidation number of that transition element. And using the oxidation number, if there is an increase in oxidation number, if the oxidation number increases, we call oxidation. If oxidation number decrease, we call that as reduction. Yes, oxidation number, it is same thing like a valency. For O levels, you will consider the oxidation number same as the valency. So if there is an increase in oxidation number, we call oxidation. And if there is a decrease in oxidation number, we call that as reduction. So example, now come back to the previous example. What we have to do, we have to write the oxidation number. Look, first thing, element oxidation number is 0. Calcium is element here, oxidation number 0. Zinc is element, oxidation number 0. Now what about others? Because in the question they will mention zinc is a transition element. According to modern definition, it is not a transition element, but according to its place, it is a transition element. So zinc normally is +2. So zinc is +2. Chlorine is group 7. So what will be the oxidation number of chlorine? So it will be -1. Calcium, what will be the oxidation number of calcium? A group 2 element? +2 or 2 plus? And what about chlorine? Oxidation number, it will be -1. Because group 7, so using a group number, you can identify their oxidation number. Now we will check the changes. Look, when we check chlorine, chlorine is -1 before and -1 after the reaction. So there is no change for chlorine, no oxidation or reduction. But what about zinc? It is +2 and it changes to 0. So if +2 changes to 0, what happened to oxidation number? It increase or decrease? If +2 becomes 0. So it decreases. So for zinc, there is a decrease in oxidation number. So if oxidation number decrease, what we call? We call that as reduction. And what about calcium? Calcium is 0, it become plus 2. If 0 become plus 2, what happened to oxidation number? It increased. So what we call increase, we call that as oxidation. So you can see now it's easy to identify in terms of oxidation number, that if oxygen is not involved, you can simply use the oxidation number and work out whether it is oxidation or reduction. Is it clear, this example? I'll give another example as well. Is it clear to everyone? The oxidation and reduction in terms of the charges. Same way, example, another reaction, you have potassium, you have chlorine reacted with potassium bromide. Even a balance or unbalanced equation does not make a difference to identification of oxidation or reduction. Now, first thing, identify the element. Their oxidation number is always 0. So what will be the oxidation number of chlorine here? What is the oxidation number of chlorine? That is 0. Why 0? Because it is element. Potassium bromide is a compound. So what will be the oxidation number of potassium in potassium bromide? Potassium belongs to group 1, so it is plus 1. Bromine belongs to group 7. So it is minus 1. Then again in potassium chloride, potassium belongs to group 1, so plus 1. And oxygen belongs, chlorine belongs to group 7, so minus 1. What about bromine, Br2? Because it's an element, so the oxidation number is 0. Now, to work out oxidation and reduction, so when you check for potassium, there is no change, but for chlorine, it was 0, become minus 1. So what happened to oxidation number? Increase or decrease? 0 become minus 1. Reduction, decrease. So we call that as reduction. And for bromine, it is minus 1 and it changes to 0. Minus 1 becomes 0. What happened? So it increases. We call that as oxidation. So if the charge increase, we call oxidation. If the charge decrease, we call that as reduction. Another example, Cu plus 2 react with magnesium, form Cu plus Mg ion. Look, for charges, the oxidation number is same as the charge or the valency as we just discussed. So for charges, you don't have to write the oxidation number because the charge on them is the oxidation number. So what will be the oxidation number of magnesium? Mg on the left hand side. Because it's an element, so it will be 0. And what about copper? But the thing is, you can have an atom, you have element and as an atom, or you may have ion of the element. If ions are there, the charge is same as a valency. Like there's a difference between magnesium and magnesium ion. What is the difference? Magnesium atom, because magnesium is having first shell, it will have 2 electrons, second shell it will have 8 electron, and third shell it will have 2 electron. This is magnesium atom. But when it changes into magnesium ion, it will lose both of the electron, so it will become magnesium ion. So the charges on the ions you have to take there as a valency, because when they lose or gain electron, they become charged, and so the charge number on the ion is same as the valency or the oxidation number. So copper 0 plus 2 becomes 0. So if copper plus 2 becomes 0, what happened to oxidation number? Decrease. So if oxidation number decrease, what we call this? We call that as reduction. And magnesium, the oxidation number increase, so what we call that as oxidation. So magnesium has been oxidized, increase in oxidation number, where copper ion is being reduced. Then another term which we use, look, the term oxidation, we call the substance for which oxidation occur, we also call that as reducing agent, we call that as reductant. Because the substance for which oxidation happen or oxidation occur, basically for that substance oxidation happen, oxidation is a loss of electron, but when it will lose electron, it will help the other to gain electron. So basically it is helping in reducing the other substance. That is why we call that as a reducing agent or reductant. And for substance which reduction reduction is a gain of electron. So for that substance, we when it gain electron, it help other to lose that electron, so we call that as oxidizing agent, or we can also say that as oxidant. So oxidation occur, we call that as a reducing agent. Reduction occur, we also call that as oxidizing agent or oxidant. So example, for copper plus 2 become copper 0. So it means reduction happen. If reduction happen, what is this? Oxidizing agent or reducing agent? If reduction happen, what is this? So it is oxidizing agent or oxidant. I'm writing in short OA. OA means oxidizing agent. For magnesium, oxidation happens. So which agent is magnesium? So for magnesium, oxidation happens. So it is a reducing agent or it is a reductant. So I can say RA. Same way, here for chlorine, reduction happens. So which agent is this? For chlorine, reduction happen. Which agent is this? So it is oxidizing agent. And for bromine, oxidation happens. So which agent is this? It is reducing agent or RA. Same way, for zinc, reduction happens. So which reagent is this? So it is oxidizing agent. And calcium oxidation happens, so it is a reducing agent. So basically the substance for which oxidation happen is a reducing agent, means it help in reduction for others. It is oxidized by itself but help in reduction for the other. And for substance which reduction happen, it is oxidizing agent which help in oxidation for other substance. Is it clear, this concept of oxidation and reduction? Now some questions. What is the definition? The same definition is there for oxidizing agent and reducing agent. The substance help in oxidation by itself. Like, what is a reducing agent or oxidant? Or oxidation is a loss of electron. The substance lose electron and help in reduction. Because when it lose electron, the other substance can gain. So it help in reduction. And what is the definition of reduction? The substance gain electron and help in oxidation. The question 4. Which equation represent reduction? The gain of electron. First thing, the charge should decrease, and the second thing, the equation should be correct to gain electron. So which one is the right answer here? Look, when substance reduction means decrease in the oxidation number. So which one decrease in oxidation? A cannot be an answer because in A it is plus 2 become plus 3. Here plus 2 become plus 3, so A and B cannot be an answer. So either C can be answer or D, because in C and D both there's a decrease in charge. But you can see which equation is correct. Iron 3 gain electron and change into iron 2. That's why C is the right answer. For D, the equation is written wrong because electron should be in the left hand side to gain. Question 10. Basically, zinc reacted with copper ion, changes to zinc ion and copper. So this is oxidation, or it is a reducing agent, and for copper 2 it is a reduction or acting like an oxidizing agent. Now what is the right statement? So for zinc is a reducing agent and it reduces the copper. So that's why D is the right statement. Is it clear? Because what happens, zinc reacted with copper. So zinc reduces the copper Copper is reduced. Why? Because reacting with zinc. So zinc is a reducing agent and it helps in reduction of the copper. In this question, four ionic equations are shown. Which statement is correct? First thing you should like from equation you can understand this is a gain of electron, this is a loss of electron, this one is also a loss of electron, and this one is also a gain of electron. So gain of electron is reduction and loss of electron is oxidation. Oxidation, reduction. So in equation 1 the copper ion are oxidized to copper. So no, copper ion are not oxidized, they're reduced to copper because copper 2 become copper, so it is a gain of electron. Or you can check the charge, plus 2 becomes 0, so it is a reduction. In equation 2 iodide ion are reduced, they're not reduced, they're oxidized because they lost electron. And you can understand from the charge, it's minus 1 becomes 0, so it is an increase in oxidation number. In equation 3 iron 2 ions are oxidized to iron 3, plus 2 become plus 3, so that is oxidation, true. And in equation for chlorine is oxidized, it 0 become minus 1 is not oxidation, it is reduction. Question 32. Copper metal donate electron to silver ion. Zinc metal donate electron to copper ion. What is the strongest reducing agent? Reducing agent means which can be for which oxidation happen. Oxidation means loss of electron. Which one can lose electron easily? Copper is donating electron to silver and zinc is donating electron to copper. So zinc is more reactive. Zinc tend to lose electron. As you can see from the statement, first there was copper. First there was copper was reacting with silver ion and it was donating its electron to silver ion so that silver will become atom and copper will become ion. So for copper oxidation happened, for silver reduction. But next what happened? A copper ion, zinc is able to displace this copper and turn into zinc ion and copper metal. So it shows copper can lose electron to silver, but silver ion, and same thing zinc atom can lose its electron to copper ion. So it means zinc can lose electron much more easily. That's why zinc metal is a reducing agent. And as the more reactive metal, higher in reactivity, the metals are good reducing agent. Like the more reactive metals are always a good reducing agent or can be oxidized by loss of electron. Silver chloride react when when it is exposed to light. Which row shows what happened to silver ion in the process? Basically, silver ion converting to silver atom when they are exposed to light. So, which one is the right statement? So D is the right one because it gain electron or reduction happen. Silver gain electron, convert into silver atom, and gain of electron is called reduction. An excess of iron 2 chloride was added to acidified potassium manganate 7. So the Roman number shows the valency. Mn is 7 plus 7 and iron is plus 2. Which statements are correct? Basically what happened in this reaction, when this is a redox reaction, when Mn plus 7 changes to Mn plus 2. So this one is purple or pink in color and this one is colorless. And iron 2 changes to iron 3. So iron 2 is oxidized and Mn7 is reduced. The purple color disappeared. That's true. Why the purple color will disappear? Because Mn2 is colorless. That's true. Iron 2 is reduced to iron 3. That's wrong. It is not reduced. It is oxidized. Manganate 7 ions are oxidized. That's wrong because they are not oxidized. They are reduced. Potassium manganate is the oxidizing agent. For potassium manganate, because reduction happens, so it is an oxidizing agent. That's also true. So which statements are correct? 1 and 4 are the correct statements. The thermite reaction can be used to produce iron from iron 3 oxide. So when you write the charts, aluminum is 0, iron 3, so plus 3, iron is 0 and aluminum will be plus 3. So aluminum 0 become plus 3, so that is reduced, oxidized, oxidation happen, or it is a reducing agent. And for iron 3 becomes 0, so it means reduction happen or it is an oxidizing agent. Which statement about these reactions are correct? Aluminum is oxidizing agent. That's wrong. It is not an oxidizing agent. It is a reducing agent. Aluminum is less reactive than iron. When you check the reactivity, aluminum is more reactive than iron. That's why it is able to displace. Electron are transferred from aluminum to iron. That's true. Aluminum lost electron and iron gain electron. And the iron in iron 3 oxide is reduced. That's true. So statement 3 and 4 are the correct statement. That's why D is the right answer. So these are some questions related to redox reaction. More we will discuss next session. Any question related to the class today? Any question or a doubt? So I'll end the session and share this recording with you.